Welcome to 6.3 Solving Trigonometric Equations Part 2. We're going to start with example 3. Solve 2 cosine 2x equals 1. Notice this is different than what we saw in example 2 because we only have a 2x as an input into our trig functions. So when you only have a 2x, we are not going to use a double angle identity. Instead, we will solve for cosine of 2x. Anytime we have a 2 multiplying by x, we're going to get twice the number of solutions. If it would have been a 3x inside our trig function, then we would get triple the number of solutions. So anytime we have a number in there with multiplying by x inside our trig function, we multiply that number by the number of solutions we would normally get. So let's go ahead and take a look at this. We are going to solve for cosine of 2x. So divide both sides by 2. Cosine 2x equals 1/2. Now we are going to make a picture for the angle 2x. So cosine is positive in quadrants 1 and in quadrant 4. And because the cosine is 1/2, that's going to be a 60-degree reference angle, or pi over 3. So in quadrant 1, we get pi over 3, but we have to figure out what angle we get in quadrant 4. So notice that's 2 pi, take away pi over 3. So we could write 2 pi as 6 pi over 3. When we take away that pi over 3, we get 5 pi over 3. So now I need to say, okay, I have pi over 3 and I have 5 pi over 3. But it's not x that equals these quantities because this is the picture for 2x. So it's actually 2x equals pi over 3 and 2x equals 5 pi over 3. Now remember, we are expecting twice the number of solutions. So normally a cosine equaling 1/2 would give us 2 solutions. So we now need 4 solutions. We need to double that. So what we have to do is we have to find another angle in this 2x world that's coterminal to pi over 3. So what we have to do is we have to add 2 pi. So when we go to do that, pi over 3 plus 2 pi to find another angle that's coterminal with pi over 3, we really want to find a common denominator. So we multiply top and bottom by 3. So we're really going to go pi over 3 plus 6 pi over 3. Instead of just adding 2 pi, we're going to keep adding 6 pi over 3. So let's go ahead. 6 pi over 3. And so therefore we get another equation to solve. 2x equals 7 pi over 3. So we just doubled this solution. So if we're at 5 pi over 3, to find another coterminal angle, we still add 2 pi, or we'll add 6 pi over 3, since that's the same as 2 pi, but it'll just make the math easier. So we get 2x equals 11 pi over 3. Now we have 4 equations to solve. We have 2x equals pi over 3, 2x equals 5 pi over 3, 2x equals 7 pi over 3, and 2x equals 11 pi over 3. But you will see there's a pattern when we go to solve. To solve for x, instead of dividing both sides by 2, I'm going to multiply by 1/2, since multiplying by the reciprocal is the same as dividing. So notice this here gives me x equals pi over 6. Let's do the same thing here. We'll multiply the left by 1/2 and the right by 1/2 in 2x equals 5 pi over 3. So this equation will give me x equals 5 pi over 6. You might see a pattern. All that's changing is that the denominators are getting multiplied by 2, or the denominators are turning into 6. And we can see that here. Or you could skip writing it, and we get here x equals 7 pi over 6, and here multiplying by 1/2 to both sides, we get x equals 11 pi over 6. So these are our four answers, and I'll go ahead and write them in increasing order. We get pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Even though our original equation of cosine equaling a half, we are expecting two solutions, because of the 2x in here, we are going to get double that. So that's why we got four solutions. And notice that even though we were adding 2 pi here, when we went and divided by 2, we got all four answers in between 0 and 2 pi. Here are some guidelines for solving with different inputs in our trig function. If there is an x over 2 in one of our trig functions, then you're going to solve for that trig function. And then you have to make sure you check. Okay? If there is a 2x inside one of your trig functions, then you're going to solve for that trig function. And you're going to get, because of the 2 here, then you're going to get double the solutions by adding 2 pi. And then if there is an x and a 2x, that's when we're going to use our double angle identities. Okay, so this is also in the notes. And of course, if this was a 3x, then that would be triple the number of solutions, and so on and so forth. Now let's take a look at practice. Solve cotangent of 3x equals 1 from 0 to 2 pi. So here we have a 3x, but there's no other trig function with an x. So we've already solved for cotangent x. So we get cotangent 3x equals 1. So we're ready for our 3x picture. So cotangent is positive in quadrants 1 and 3. And whenever we have a tangent or a cotangent equaling 1, that's going to be a reference angle of 45 degrees, or pi over 4. Remember, pi can be written as 4 pi over 4 in this situation, so this angle in quadrant 3 is 5 pi over 4. So therefore, we get that 3x equals pi over 4, or we get 3x equals 5 pi over 4. Now, on our 3x graph, now let's find some coterminal angles, because we need 3 times the number of solutions because of the 3x going into our trig function. So we are expecting from this 3 right here, triple the number of solutions. So instead of 2 solutions, we are expecting to triple that to get 6 solutions. So if I'm at pi over 4 and I want to add 2 pi, okay, so let's kind of think about that. If I'm trying to add 2 pi, if I'm dealing with pi over 4s, I'm going to write that as 8 pi over 4. So I'm going to add 8 pi over 4 to get my next equation. 3x equals 9 pi over 4. Since I need to triple this solution, I'm going to do it again. So first, I added 2 pi or 8 pi over 4 to get 9 pi over 4. Now I'm going to add 2 pi again, and I'll write that as 8 pi over 4. So I get 3x equals 17 pi over 4. Now I need to do the same for 5 pi over 4. First, I add 2 pi or 8 pi over 4. So 3x equals 13 pi over 4. And I need to do it again, so I'm tripling the number of solutions. So I get 3x equals 21 pi over 4. Now let's go ahead and solve all of these 6 equations. Hopefully we'll see a pattern pretty quick. Let's take a look at 3x equals pi over 4. Instead of dividing both sides by 3, I'll multiply by 1/3. And this is going to give me x equals pi over 12. Let's do the same thing for 3x equals 5 pi over 4. Multiply both sides by 1/3, and this is going to give me x equals 5 pi over 12. So I'm hoping we see a pattern at this point. We don't write anything else. We just go to our final answer. But I'll go ahead and just write that out just so you can see it. So once we've solved all of the equations by dividing both sides by 3 or multiplying by 1/3, we get pi over 12, 5 pi over 12, 9 pi over 12, 13 pi over 12, 17 pi over 12, and 21 pi over 12. However, you might notice that 9 pi over 12 can be reduced by 3. So that one we end up getting 3 pi over 4. And 21 pi over 12 can also be reduced by 3, so we get 7 pi over 4. So our final answer is pi over 12, 5 pi over 12, 3 pi over 4, 13 pi over 12, 17 pi over 12, and 7 pi over 4. So notice our cotangent equaling 1 was going to give us 2 solutions, but because of the 3 multiplying by the x, we got triple the number of solutions. And the way we found that is in our picture for 3x, we found an angle and 2 coterminal angles for each by adding 2 pi or 8 pi over 4. So we ended up getting 6 solutions, which is triple the 2 solutions we were expecting for cotangent equaling 1. I hope you enjoyed this video. See you next time.